Hello people, who is watching this? So this is an introduction video to the Versa framework, which is an ECS framework for Unity. And in this video I will explain to you what is an entity component system paradigm and why Unity isn't one, and why is it so important and why is it so cool and dandy. Right? Let's start with the formulation. So entity component system, or short ECS, stands for an entity plus component plus systems. It doesn't stand for a component-based system, or something like that, or entity framework, or whatever other people call it for different reasons. It is exactly the three words combined. It is an entity plus component plus a system. So so in ECS, let's abstract from Unity and abstract from everything. What is a pure entity component system? So in pure entity component system we have components, and the components are basically a flat data, so just that exists registered somehow in the system, and they're unified by an entity which acts as a root object. It depends on implementation, but in general the idea is that you can combine an arbitrary set of components into something that you call an entity. An entity is a way to abstract those components into something that has a meaning, for example, for your game. And in pure CS, keep clicking new file instead of new layer. Alright, so imagine we have all those components just laying there as a data. In pure CS, components don't do stuff. They absolutely devoid from any logic. What they do is they hold data, so they're basically just ports, plain old data. They're of course combined by entities as a way to access, group them together and act on a group as a single thing. However, they represent just a flat data world of flat things that don't do anything themselves. So they just entries of some type of data. Now system is an actual user of that data. A system typically has a single responsibility. For example, it moves the clouds. So a system observes the data in the game from top down without the data doing anything, absolutely, and the system then modifies that data every frame. So every frame the update happens, system will iterate over the components it is interested. Let's say these are components that have cloud data, so inside you can have something like a cloud, and we would have something like position, rotation, and whatnot. And every frame the system will look at the clouds and decide where to move them, modify their position, rotation, and so on and so forth. Now it seems pretty straightforward approach, and it seems like that's how you do it typically, right? But you don't. If you think of it, if we have another system that also modifies clouds, but this one, let's say it implements a global wind, so it's not only interested in clouds, to which it adds some property, like for example size or something. It's also interested in a component that holds data about the wind, so it will modify the wind. Or the system right now gets too many responsibilities, but whatever. So if we disable this system will continue working. If we disable this one still will be working correctly. They don't communicate with each other. Absolutely. All they do is modify the data that currently exists in an application. This way they are completely decoupled from each other. It is called data-driven approach. This is what pure ECS does. At any moment, the whole simulation is just basically components that are static, that represent only data, and if you disable all the systems, if you remove them, delete them one by one, any configuration of systems, nothing will, they won't care. Systems are interested exclusively in the components that they need to work with. If the components don't exist, they don't do anything. If the components exist, they do something. It is a very robust way to work and have a very clean and decoupled architecture, and this is what ECS essentially does. Now, Unity, I'll stop actually here and I'll upload another video